All right, let's wrap up Chapter 4 with 4.8, Applications and Models. So 4.8 is actually nothing new. It's just taking everything we've learned and putting them into some real-world models, some real-world applications. So let's get started with the first example. First thing we're going to be looking to be able to do is we're going to be given an angle and a side length, and we need to find everything else. All right, so the first thing that's going to be easy to do is to figure out the remaining angle here, right? Because we know that there's 180 degrees in a triangle. We've used up 90, and so there must be 90 left for angles A and B. If we subtract 34.2 from 90, we're going to end up with 55.8. So we can right away figure out the third angle, 55.8 degrees. All right, now we need to figure out the other two sides, and for that we're going to need to use some of our trig functions. Let's go ahead and start by figuring out A. We can figure out C if we wanted to. It doesn't matter which one you go with first. You'll see why in a second. I know that the relationship between A and B is an opposite over adjacent relationship. That's a tangent relationship. So the tangent of an angle, which we know, 34.2, is equal to A, the opposite, over the adjacent, 19.4. And so to get A by itself, we can multiply 19.4 times the tangent of 34.2. This is a calculator problem. So we'll go to our calculator. And so what do we have here? 19.4. Let me make sure that we're in degrees, and we are not. We're in radians, so we've got to change that. Degrees, get back in here. 19.4 times the tangent of 34.2. Hit enter, and we've got 13.18. And so we'll round that to 13.2. Since they were giving us just one decimal place here, we'll go with what the problem has already started with in terms of decimal places, 13.2. All right, the last thing we could do, we could find C two different ways. We can do Pythagorean, 19.4 squared plus 13.2 squared equals C squared. Or we could do another trig function. For instance, we could do the cosine. Cosine of 34.2 is the adjacent 19.4 over C. So either way is totally fine. And let's see, let's go ahead and just do the Pythagorean here. We're going to square our answer, and plus 19.4 squared. And we'll take the square root of that, and we get 23.5. 23.5 for the hypotenuse. So we've gotten every single side. Your job is to do the same thing on problem 5. All right, so we've got a situation here where we've got a ladder that's 110 feet long. We've got an angle of 72 degrees. This is an angle of elevation. Okay? And we want to figure out how high we can go up, to what height can we get up to the building and reach with our ladder. So we're looking for an opposite side. We have a hypotenuse, and so that's a sine problem. Let's set it up. Sine of 72 is opposite over adjacent. Let's get A by itself by multiplying both sides by 110. And plug it into your calculator. Let's see what we get. 110 times the sine of 72. And we get 104.616. 104.6, and we were in feet here. All right, so we're just trying to figure out which trig function we want to use. Is it sine? Is it cosine? Is it tangent? And we'll be able to figure out the missing side. See if you can use the same thinking to figure out the answer to problem 19. All right, example 3, very similar, but now a two-parter. So we want to figure out the height of this smokestack, which is from here to here. Let's figure out the big triangle first. So on this one, we know, let's use green here. So we're going to figure out this large triangle. In the large triangle, we know that the adjacent side is 200. We want to figure out the opposite side. And we know that the angle is 53 degrees, the big angle. So opposite over adjacent is tangent. Tangent of 53 is, what do we got here? Opposite, so we don't know that, and they don't give us a angle either. It's S plus A. Just lost my pen. There we go. S plus A combined is our opposite side. The adjacent is 200. And so let's figure out what we get there. 200 times the tangent of 53. We get 265.41. So that's S and A combined. Now let's just figure out A, because if we do A, we could just use this triangle. And we do know that the smaller angle in here is 35 degrees. So on this one, we could say the tangent of 35 degrees is A over 200. Still opposite over adjacent. Let's figure that out. So 200 tan 35. And we get 140.04. Is A. Alright, so if this is S plus A, and this is A, we can certainly figure out S by just subtracting 265.41 minus 140.04. And we're in business here. What do we got here? 37 and 125. So 125.37 feet is the height of that smokestack. Alright? Same thinking on 23. See if you can figure it out. Remember that there are 60 minutes in a degree. Alright, let's find the angle of depression of this swimming pool. We want to find this angle down here. Remember, angle of depression is from a horizontal line swinging down. So on this one, we know that our opposite side here is going to be 2.7. And our adjacent side is 20. That's a tangent problem. Tangent theta is 2.7 over 20. All right, I need theta by itself, so we need to switch this around. How do we switch things around? We use inverse tangent. So the inverse tangent of 2.7 over 20 will find the angle for us. All right, and do we want this in degrees or radians? I'm assuming that we want this in degrees. Doesn't really make sense to talk about the angle of a pool in radians. So let's do this. Second tangent, 2.7 divided by 20. And 7.69 degrees is the angle of that, the angle of depression of the pool. All right, inverse. Use the inverse operations for number 29. Okay, so we're going to introduce something called bearings. And so bearings is something where if we have north, west, south, east, we've got direction involved, right? We're going to be able to figure out, okay, 35 degrees, but from where? From the south, or from the north, or from the east? So bearing south 35 east means start by pointing south and then spin 35 degrees to the east. North 80 degrees west means start pointing north and then spin 80 degrees to the west. Okay, so we're not always just starting from the positive x-axis anymore. North 45 degree east, start by pointing north, spin 45 degrees to the east. All right? So we're going to use that to figure out problems like these. We've got the ship that leaves port. Port's over here. It travels 2 hours at 20 nautical miles per hour, so a total of 40. It then decides it wants to change course. So it changes course north 54 west. So from pointing north, we spin 54 degrees to the west. And then we keep traveling another hour, 20 nautical miles. All right? Our new job is to figure out, okay, what is our bearing back to port? If we needed to travel back to port, what degree would we travel? And how far away are we? See, so a couple things here to figure out. One thing that we'll start with here is we know a couple right angles. That's a right angle in there. Okay, I know that this angle in here would be 90 minus 54, so that's going to be 36 degrees. I know then that this is also going to be 54, because this is a right angle down here. Okay, so we know a couple of the angles in here, and from there we can start to solve. So one thing that we could do is start by solving for C. So we want to find, let's start by solving for D or B. All right? It would be most helpful to solve for D, because if we can solve for D, then we're going to have one side of this big triangle, the big one. All right? So let's start by solving for D. If we did that, we could either use the 54 or the 36. Let's use the 36. So 36 degrees. I want D. I know the 20. That's the hypotenuse. So right now it's adjacent. D is adjacent to 36, and the 20 is the hypotenuse. Which trig function is that? That is cosine. So cosine 36 is D over 20. Let's punch that into the calculator and figure out what we get. 20 cosine 36, 16.18. So now we know D. D is 16.18. All right, so now we know the length of the long side here. This whole thing is going to be plus another 40. That'll be 56.18. All right. So we have one side. Can we figure out the other side? Let's figure out B. So B would be the sine of 36. Would be B over 20. Right? Opposite over hypotenuse. Let's figure that out. Sine of 36 times 20. 11.76. All right. Now we know the long side. We know B, the short side. Can we figure out C? Absolutely. We've got a Pythagorean theorem. 56.18 squared plus 11.76 squared is going to be C squared. Let's figure out what that is. So we'll square our answer. Where are we? There we go. Plus 56.18 squared. And we'll square root that. And end up with 57.4. So C is 57.4. All right, last thing to do is we need to figure out this angle in here. All right, so what we could do is we could figure out the big angle, and then we would just subtract the 54. All right, from that angle, let's use B and the 57. From that angle, B is adjacent, 57 is the hypotenuse. So that's cosine. The cosine of theta is B, which we already know B, 11.76, over the hypotenuse, 57.4. How do I get theta by itself? We use the inverse cosine. And we'll plug that into our calculator. Making sure we're still in degrees, which we haven't changed it in the calculator, so we should still be in there. Second cosine, 11.76 divided by 57.4, and 78.2 degrees. The whole thing is 78.2 degrees. Let's subtract the 54. And we end up with 24.2 degrees. All right, so we need to know our bearing. If we were pointed north, we would have to swing from here all the way over to here. What would that end up being? Okay. The bearing there would be 180 minus 54, 126 degrees. We started by pointing north, and we spun towards the east. So that would be our bearing. All right, a lot going on in this problem. I'm imagining we'll probably go over this again in class. Okay, but do your best. See if you can work on 37. See if you can set up the drawing at the very least, and then solve as best you can on 37. Okay, let's finish here by talking about this is harmonic motion, which we'll do the formula for in a second. But harmonic motion is just any situation where we go down and then back up in repeated motions. Okay? So negative 10 would be our maximum negative displacement. Positive 10 would be our maximum positive displacement. And we just go back and forth and back and forth. Okay? All right. If that happens, we can use either a sine or a cosine curve to do it. It doesn't matter which one. It just matters where we start. If we start at 0, it's going to be a sine curve, because remember, sine starts at 0 and goes up. If we start at the displacement, then you're going to use cosine, because cosine starts high and then comes back down. All right. The period is 2 pi over b. Only on this one we're going to use the w. Does anybody remember the w? Okay. If you said omega, good job. So we're going to use omega there. And frequency is the reciprocal of period, so omega over 2 pi. All right. So for that drawing that we had a second ago, where it went up and down 10, let's figure out the equation for this thing. All right. Period is 4 seconds. So we know on this one we're going to, let's just use sine, assuming we start in the middle. All right. And for this one we're going to say d equals, what's our a? Our a is going to be the displacement, so 10 sine, and let's figure out our b in here. Remember that period is 2 pi over omega, and we know the period is 4. So let's multiply by omega. 4 omega is 2 pi, and so omega is, divide by 4, divide by 4, omega is pi over 2. And we put an x on the end of it, but in this case it's t for time. That'd be our equation. What is the frequency? The frequency is the flip of the period, and so that is going to be 2 over pi. It's going to be our frequency. Okay, just flip it on over. Your job on 53. See if you can get it. All right, I believe this is the last one. Yes, it is. All right, so we're given our equation here. Let's find 4 things. First one, A, is easy. What's the maximum displacement? That's just 6. That's the amplitude. Let's find the frequency. To find the frequency, first we would do the period and flip it over. So frequency, instead of 2 pi over omega, is omega over 2 pi. In this case, omega is 3 pi over 4 over 2 pi. And so that's 3 pi over 4 times 1 over 2 pi. And let's cancel some pi's, and we'll get 3/8 for our frequency. Let's find the value of d if t is 4. So d equals 6 cos 3 pi over 4 times 4. Thankfully the 4's cancel. 6 cosine of 3 pi. 3 pi is the same as 1 pi. Cosine there, that's the x value. That turns into -1. Plug it into your calculator or look at your unit circle to get that. And so -6 is our answer there. All right, lastly, let's find the least positive value for t for which d is 0. So we're going to make d 0 and solve for t. All right, we can divide by 6 right off the bat and just clean that up a little bit. That's still 0 equals cosine of 3 pi over 4 t. And on this one, we would want to get rid of the cosine by putting an inverse cosine on both sides. So now we have the inverse cosine of 0 equals 3 pi over 4 t. And the inverse cosine of 0, that says which angle gets me a x value of 0, and the first one that we come to is pi over 2. So pi over 2 equals 3 pi over 4 t. I got this just by looking at the unit circle. Where is the x value 0 on the unit circle? Let's clean this up. Let's solve. We can times by 4 over 3 pi. Those cancel. 4 divided by 2 is 2, so we're going to get t is equal to 2/3. Right, we'll have a minimum after 2/3 of a second. All right, your last one is 57. See if you can get that. And we are all done. Questions, we'll be sure to go over it in class. Good luck.